Let's take a look at some of the best and creative mechanisms that the FTC community has made this week in the DECODE season. I think they've got a really fascinating way of indexing here. And a lot of teams, I'm Coach Pratt, and I've been teaching robotics and design for over a decade now. This week, there's been some pretty major advancements in the indexing category. So let's go take a look at some of the robots. First up here in indexing category, we've got Team Black Box 3355 or 355. I think they've got a great little indexing prototype here. Obviously, it's going real fast, so these things are flipping out. But I do like this little polycarbonate section that is holding in, and it's able to rotate itself around. Now, they may need to, well, obviously this is first testing and slow it down, maybe add some sort of cap on the top. But this is a great starting point on how teams might go about rotating something around. There's also Team Top Secret 8907. I think they've got a really fascinating way of indexing here. And a lot of teams are indexing things horizontally. This team has a vertical sorting section. And there were some earlier prototypes in the season of vertical indexers being a little bit slow and perhaps not be able to get a ball in. But I think this is a really creative way of actually keeping in some of those horizontal design constraints. Some questions I have about this design. I love this little arm that just kind of kicks things up. One, it's not clear in this where the color sensor is as it goes through. Do they have any sort of camera sensing so they can flip through and rotate these sections? Another question I have is, how does the ball get in? I'm not sure at what side. It looks like on the left-hand side, you've got this wheel here, and that's where that ball is able to fall in. So I wonder just how wide that intake section is. And maybe there's a little bit of extra compliance could be added, like instead of having such a hard cutoff at the bottom, maybe that bottom section could have wider arms to be able to bring that in. I think this is a great initial first prototype to really get into those idea of those patterns and motifs. So next up, we've got Team Unimate here. They have another similar kind of idea for a indexer. This one's not powered at all, but you can see the intake's able to come in, it's able to rotate itself around. I think that similar to the first design, as well as that last time we just talked about, teams that are doing indexing across concepts like this, I'm wondering how wide they're able to pick these balls up. So it works, but it's quite a narrow intake section. So this might work really well for autonomous, but I wonder how well this is going to work when it comes time to do teleop and having a much wider intake to be able to scoop and funnel these things in. Perhaps even a vectored ball intake might help with this. In any case, excellent work there, Team Unimate. I want to show off here Team 12470, because we can see down in the bottom of the robot here, they've got a functioning spindexer sorted up inside of their autonomous. And we can see that despite loading up 3 purple balls right at the start, and I think that's a really good strategy at the start, so they clearly don't have any April tag detection set up yet. It is cool to see this indexing set up as a pretty high, well, not high throughput, but pretty successful strategy on the autonomous section. So 12740, excellent work on that. Last up in the indexing section here, we've got Shooting Stars 23240. And I want to take a look at a specific section in the video here. You can see down a little bit in the bottom here where it's starting to index. But right in here, we can see that it's going to pick up a ball, rotate, pick up a ball, rotate. And then it's able to spin itself back around. So let's take a look at this. And what's interesting about this is that the whole spindexer itself seems to be lifting up once it's able to fire through. So let's take a look. The whole spindexer lifts itself up to be able to rotate and then pick itself back in. And it looks like they're probably using 5 or 6 inch PVC pipe as a way of holding this together. It kind of looks like there's some holes in there. Really interesting linkage mechanism. I'd be curious to see or get a much closer look from this team, see how it is that they're lifting up. Is it a simple linkage? Is it a rack and pinion system? Is it perhaps a linear actuator? Oh, is it a spring latch mechanism? It's an interesting way of being able to index around, and it keeps it relatively compact despite it looking like a gigantic cube. Nice job on that, and thank you for sharing, 23240. Next up, we've got some intakes here. This is, again, from Team Black Box here. I like their intake in this section, just a little bit of compliance at the front. You can see some 3D printed TPU wheels at the front there, and it's a pretty successful way of being able to pick things in. The reason I wanted to highlight this section is I want you to notice just how little lateral movement you have in that ball and forward movement you have in that ball. When that ball touches those compliant wheels, the ball is not moving forward. The ball is staying where it is. And I think that's going to be something that teams are really going to have focus on, especially in the autonomous period, so that you don't have to drive completely into the wall to be able to pick the balls up. You can just touch them and they come into the robot. Grab it and control it, I think, is a really kind of big concept here. So it'll be nice to see. And what I'm curious about to see is if the robot is moving faster, how well does this still function? Good job on that one, Team Black Box. Next up, we've got Team 12736, and they've got a simple little handoff from their intake here. They've got a rubber band intake that we've been seeing start to develop in some of these teams. And then there's a little scooped up section, and then it looks like there's a couple Andy Mark Gecko wheels, perhaps an Andy Mark compliant wheel that they've cut some sections off to be able to push it up. And I think it's pretty cool. One thing I'm curious about is as the ball kind of sits here, they might have some other mechanism to be able to push it up, and they will likely have to have one. It looks like there's a servo in the back to be able to force this back up. They've also got little vectored wheels here, and I wonder how frequently these little vectored wheels are working on their intake. In any case, very cool work. Love to see it. Next up, we've got the same robot here from 12736, and we can see that they've clearly got some method of being able to actually launch their ball actually up and in. So we can see it's able to intake itself up, and then looks like 3 balls are able to launch themselves up and out. Yes, 3 balls are without another ball pushing in. So in any case, great work on this one. And then let's take a look at some transfers here. We've got Team 23554, Blue Goggles Robotics. And I wanted to highlight this one because I love seeing PVC pipe for this. They've got looks like some simple self-adhesive gripping tape. And then they have what looks like, this may be tank treads to be able to force this up. I'm not 100% sure what this is, but it looks like it's a pretty successful way of bringing their section up and through the top. So using some common industrial materials and the things you can find from a hardware store, you can really see these robots can perform quite well. Question I have for them, and I'm sure this is still in their intake section, they do have this section here that's able to try to funnel it in. Clearly, in this case, it's not enough of a funnel for what it is they're looking for. I'd also be curious at just how vertical they can get this section. And off of a single servo, it seems to be pretty successful in being able to kick things up. I wonder if they could also do a little cutout scoop in the bottom here so that the ball doesn't have to touch all the way up to the top to be able to force itself out of that tube. Moving on over, we've got another transfer here from Team 16757. I think it's cool seeing some Augur style, almost like a grain mill, be able to push itself up and over. Let's go back. There we go. So they've got a simple little wheel here that looks like they've got a little arm that kicks it up in, and then it's able to transfer itself up and onto their robot. One thing I am curious about is how fast does this go? And then how reliably is this able to push this ball up? It looks like it loses some of its points at the end. So I wonder on this Augur, could they make the tip wider up the top of some sort of compliant section so that it can still be nice and tight to their edge wall, but allows them to be able to give themselves a little bit more kick at the end? Because we can see this little servo here is trying to spin that ball out, but it's not quite enough. We can also see it's got some sort of setup here for the ability to do two-wheeled or Next up for autonomous, we have FTC 9707. And I wanted to highlight these guys because they've got a pretty far shooting autonomous. So they're able to launch those balls in right from the end. I'm curious, it looks like they've got some sort of debugging light. I'm not 100% sure what this debugging light is for. They may be aware of what its purpose is, but it's not inherently clear right from the section, right from the get-go. One thing I do want to talk about is it seems like their second ball tends to miss. And it might be the fact that they're trying to put too much throughput through a flywheel before knowing that their flywheel has caught itself back up in speed. So perhaps adding a little bit more of a delay between the time that those balls end up launching might end up making things a little bit more consistent for you as a team to ensure you have that sort of minimum RPM that you need to be able to fire out those goals. One thing else I'm curious about is we notice that they're only firing from the far range. They neglect these 3 balls here, and I think it's going to be really important for teams to be able to work with their autonomous pattern. So it's great to have an autonomous setup where you're able to grab more spike markers. But if your other team already has an autonomous set up, you may need to think about how your autonomous meshes with another team's autonomous, in that you may have a robot here at the front that's able to grab these 6 here, and then you at the back launcher, in my opinion, should be prioritizing 3, and then these 3 sections here, just to make it a little bit easier to work with your team. In any case, excellent work on this 9707, especially for preparing if your teammates have no autonomous. Last up here, I want to show off Muskoge's 9235. I think it's just a great way of using some simple materials. I think this is just like a mesh screen setup here to take something similar to a Go Build a Starter Bot and make it out of their own materials, but also show just how effective some of these things can be, especially at the first qualifier tournament, using simple designs that work well. And they're clearly doing a lot of driver practice on this, which is great to see. And I think that being consistent right from the start and being able to have accurate, reliable sections, these are totally viable robots to work with. And there's absolutely nothing wrong with taking those starter robot designs and then building up from there. And then last up here, we've got Team Astra Machina. They've got a pretty fantastic looking autonomous here. It's pretty darn consistent, and I quite like seeing this. It's an excellent looking robot. I think it's quite consistent already from the start. This team has been doing and showing a great example of autonomous tuning and testing their robot over time. One thing I am curious about on this robot, and I think needs to be thought about on this robot, is their intake mechanism. And we talked about this a little bit earlier about grabbing it and owning it. You notice that these boot kickers, it does push the balls out of the way before they actually start to come up into the design. So I can't quite see their intake fully here from this. We know that they've got quite a few rows of boot kickers here. You can see that 1, 2, 3 different rows of boot kickers. I wonder if they need just so many boot kickers on that. Like, it looks like there's probably close to 30 different boot kicker wheels on this. Do you actually need that many boot kickers on there? Is the mechanism just as reliable if you weren't to use that many boot kicker sections? So that as you come up to these balls, rather than pushing them out of the way and having to use the sort of wall area to be able to grab those, are you capable of grabbing these without having to push up against that wall? In any case, super impressive work from Team Astra Machina here, and I love seeing the iteration on their design over time. I'd like to hear how your team is doing down in the comments below. What do you think the meta is going to start developing into now that we're starting to move into some sort of qualifier tournament season? If you'd like to submit your robot to the next episode of FTC Fridays, you can find the form down below, where you can submit any sort of video link that you'd like to potentially get featured here. If you want more access to robotics resources, you can consider joining my community for things like CAD, code snippets, and then some feedback from myself as well. If you got questions, comments, let me know in the comments down below. Otherwise, best of luck out there this FTC season.